All right, ladies and gentlemen, study guide for the Unit 2 test in Advanced Algebra through Data Exploration. Here we go. So the first one, complete the table of values for the sequence defined by the explicit formula. All right, so we have our explicit formula, U sub n equals 4n plus 2. All right, so we're going to go ahead and we're going to plug in the 1. So 4 times 1 plus 2, that's going to be 6. So the first number in the sequence is 6. Okay, now we can plug in the 2. So 4 times 2 plus 2, that's going to give us 10. Okay, continue. 4 times 3 plus 2, that's going to give us 14. Once you see the pattern, you do not have to keep plugging the numbers in. Okay, you can see that the pattern is going up 4. So now we've got 18, 22, 26, 30, 34. Now, hopefully you see the relationship within the explicit formula. The 4 is the pattern. Okay, so keep that in mind. We'll talk about the other number 2. We might see that later on in the packet. All right, now what type of sequence is this? Well, since we are adding each time, it is arithmetic. Explain why. It's because we are adding 4 each time. All right. Number 3. From the explicit formula U sub n equals negative 6n plus 20, find U30. So we're going to plug in the 30. So negative 6 times 30 plus 20. Okay, again, go ahead, feel free to use the calculator, and you should get negative 160. Number 4, from the sequence given, find the explicit formula. A table has been provided to assist you in finding the formula. All right, so you can see the first number is 7. That has been given right there. The next number is 10. The third number is 13. The fourth number is 16. The fifth number is 19. All right. Now, the pattern is going up 3. Okay, so that's going to give us part of our explicit formula. That 3 is immediately following the equal sign, followed by the n. Again, look back at the first problem. You should see that connection. All right, now, if we go backwards, what's under the 0? Well, if we go backwards, we're going to take away 3, and so 4 would be underneath the 0. And then you can simply check, oh yeah, 4 plus 3, that's going to give us 7. So the 4 is what follows behind the n, so we're going to put a plus 4. All right, the next problem, we really didn't see something like this, but it's all connected to everything we've been learning. Suppose you are riding a bike from Melrose. Okay, Melrose is right there in orange, which is 11 miles from Sauk Centre. Okay, so Sauk Centre is right here. That's 11 miles between Melrose and Sauk Centre. Now, you're riding towards Columbia Heights. All right, Columbia Heights is right down in here, lower right corner. So you're going to ride a bike. Granted, you can't ride on the interstate, but imagine that we were. It wants to know, okay, and you're riding at 10 miles per hour, okay, 10 miles per hour. What is your distance from Sauk Centre after biking for 4 hours? Okay, well, it's asking that you're biking from Sauk Centre. Well, what it says up above is Sauk Centre to Melrose is already 11 miles. Plus, you're biking at 10 miles per hour, and it wants to know how far have you traveled after 4 hours, okay? 4 hours. Well, that's what you're multiplying by. So 11 plus 10 times 4. So far you have ridden 51 miles. Okay, think through that. Now, write an equation that represents your distance from Sauk Centre after X hours. Okay, so now we're going to use X and Y instead of the U sub n and the n, because this is an equation, not an explicit formula. It's an equation. All right, so instead of U sub n, we're going to use Y equals. All right, now I'm going to put the 10 first, and then I'm going to put the X, because the X, the 4 is what we replace the X with, and then the 11 miles from Sauk Centre that is between Melrose and Sauk Centre. Okay, think about that problem. It's not that difficult. It's related to everything we've been doing. It's just putting it into context of a word problem and looking at a map. All right, let's go to page 2. All right, on page 2, we are going to use this formula. Partial credit will be given, so make sure that you show some of the work. All right, so it wants, this is the sum formula right here. So find the sum of the first 35 multiples of 5. Okay, well, the first number in the sequence is 5. The 35th number in the sequence, so this is the first number, this is the 35th number, is 175. And that's, so we're going to plug numbers in. So I'm going to draw some arrows. So the 35, that's the how many, so that's first. There are 35 numbers in the sequence. Okay, the first number in the sequence is 5 plus the 35th number, or the last number in the sequence, is 175. And then we divide all of that by 2. So we plug it in into the formula. Now take your calculator. Okay, take a couple seconds, type that in, and we will have our answer. Okay, you should get 3,150. All right, the next problem. Again, this symbol is telling us to find the sum. We're going to start with the first number in the pattern and go to the 20th number in the pattern. So we only need to know those two things. So I'm going to make a small table. I only need to know the first number in the pattern and the 20th number in the pattern. Okay, so I'm going to plug the 1 in. So 2 times 1 plus 6 is 8. Now I'm going to plug the 20 in. So 2 times 20 plus 6 is 46. All right, I'm going to plug everything into my formula. Okay, I'm not going to color code it this time. I'm just going to plug them in. So there are 20 numbers in the sequence times the first number is 8 plus the last number is 46 divided by 2. All right, type that in. You should get 540. So the sum of the first 20 numbers in that sequence is 540. Okay, number 8. There is a concert hall that has 60 seats in one row, or in row 1, sorry. 65 seats in row 2, 70 seats in row 3, and so on. The concert hall has 30 rows of seats. Hint, set up a table to help solve the problem if needed. Use the bottom of the page for scratch work. All right, so I'm going to go down here to my table. So the first row has 60, the second row has 65, the third row it says has 70. So it looks like it's increasing by 5 each time, right? So the fourth row it had 75. Okay, now in this last one, all right, it says there are 30 rows of seats. So I'm going to put my 30 there, and I'm going to figure out how many seats are in that 30th row. All right. Now, in order to figure out that, I'm going to need to first figure out my formula, or my explicit formula. So what I need to do, okay, so I know this is going up 5. Okay, I'm going to go backwards. Now, if there was a row 0, there would be 55 seats in row 0. Okay, but again, there is no such thing as a row 0, but if there was, there would be 55 seats there. Well, just like on the front page, I've got everything that I need for my formula. So it's 5n plus 55. Again, the pattern is 5, so 5n, and then the number under the 0 is 55. Well, now I can figure out how many seats are in the 30th row. So I can go 5 times 30 plus 55. So that's my explicit formula. So, A, how many seats are in the last row? Well, again, that's 5 times 30 plus 55. So there are 205 seats in the last row. B, how many seats are in the concert hall? Just like on this page, we're going to use that formula. So there are 30. Okay, let me fill this in down here first. So this was 205 there. So there are 30 rows. So we're going to go 30 times. How many seats were in the first row? 60 plus 205 seats in the last row divided by 2. So we're using that formula that's on the same page. Okay, we plug that in. There are 3,975 seats in this concert hall. Okay, part C, write out the summation for it. Well, it's n equals 1. That stands for the first row, to the 30th row. And then beside it, we write our rule, the 5n plus 55. And that's the symbol that is used for the summation of that sequence. All right, let's move on. Page number 3. All right, so the first 2 pages dealt with everything arithmetic. Now, page 3 deals with everything that is geometric. So complete the table of values for the sequence defined by the explicit formula. So again, we're going to plug in, here's our explicit formula, we're going to plug in the 1. Now, that's an exponent, so 4 times 2 to the first power, which is 8. 4 times 2 to the second power, that would be 16. 4 times 2 to the third power. Carefully type that in on your calculator. That's 32. Okay, the pattern is multiplying by 2. And you should notice that that's the ratio or the rate. That's what's in the parentheses. Okay, I'm going to continue multiplying by 2. So 32 times 2 is 64. Times 2 again is 128. Times 2 again is 256. Times 2 again is 512. Times 2 again is 1024. And I already answered this. Is the above sequence arithmetic or geometric? It's geometric. Why? Because we are multiplying by 2. Please be specific. Okay, number 11. At any point, if I'm going too fast, you can pause the video. Okay, number 11. We want to find the 15th number in the sequence, and here is our explicit formula. So 200 times 0.80 to the 15th power. And it says round your answer 2 decimal places. Okay, you type that into your calculator, you should get 7.04. Number 12. From the sequence given, find the explicit formula. So we're going to go backwards and find the formula. All right, so let's fill in the table. So we've got 6, then the next number is 9, and then the third number is 13.5, the fourth number is 20.25. All right, now we're going to go backwards, but in order to do that, we have to know what we're multiplying by. So this is where I'm going to pull up the calculator, because I'm not sure what I'm multiplying by. So I'm going to go backwards. I'm going to pick a number. I'm going to pick the number 9 and divide it by 6. So let me pull up the calculator. So 9 divided by 6. Okay, looks like we're multiplying by 1.5. Let's pull up another one. I'm going to take 13.5 and divide it by 9. I'm just going to double check. 13.5 divided by 9. Okay, so we're multiplying by 1.5. Okay, so we got to go backwards now. So what I need to do is I need to take the 6 and divide it by, now hold on here. Yeah, that was right. We're going to take 6, we're going to go backwards. So we're going to take 6, and instead of multiplying by 1.5, we're going to divide by 1.5. And that's what goes under the 0. Again, think about what I did there. All right, so get back to here. So this is a 4. Again, we went backwards, and we divided to figure out what's under the 0. Now, this formula, remember, is u sub n equals u sub 0 times the rate or the ratio to the n power. So our explicit formula here is the u sub 0 is 4 times the rate, which is 1.5 to the n power. So there's your explicit formula. Okay, number 13, let's say you drop a super ball from a height of 500 centimeters. This particular super ball will rebound 70% of its original height. Remember, we never directly work with percents. We will work with the decimal. How high does the ball rebound on the fourth bounce? Okay, so again, we're going to use the u sub n equals the u sub 0 times the rate to the n power. Well, the u sub 0 is the original amount. The ratio is the 0.70, and then the fourth bounce to the fourth power. Type that into the calculator, and we should get 120.05 centimeters. How many bounces does it take for the rebound height to be less than 60 centimeters? Okay, I'm going to use the calculator here. So I'm going to redo this. And what I'm going to do is in my y equals screen on the calculator, I'm going to type 500 times 0.70 to the x power. Okay, so again, I'm going to use my y equals screen to help me, and then I'm going to go to the table. So if you have to rewind this and watch it again, please do so. So here we go. So I'm going to go to my calculator. First of all, I need to make sure that it's in function mode. It is. Y equals. All right, so here we go. So 500 times 0.70. Now I'm going to hit the caret key for the exponent, and I'm going to put an x. Okay, so I typed in that into my y equals. Now I'm going to go second graph, which is the table. Now the question is, how many bounces until it is below 60? All right, well, let me go down a little bit. So you can see right here, the top is 0,500. That's where it started. And 1 bounce is 350. 2 bounces is 245. 3 bounces is 171.5. 4 bounces is 120. 5 bounces is 84. And look at there, there's the answer. 6 bounces is 58.8. So that's below 60. All right, so it took 6 bounces. Okay, next page, please. Now, this again is all geometric. It says use this formula right here for problems 14, 15, 16b. Show work, partial credit will be given. All right, so we are given this pattern. It says find the sum of the first 22 numbers in this pattern. All right, well, this is a u sub 1. That represents the first number, 5, times 1 minus. Okay, now, what is r? All right, well, we have to figure that out. So, again, it's geometric. So what are we doing each time? Okay, 5 to 10, 10 to 20, 20 to 40. I believe we are multiplying by 2, folks. So the r is a 2. The n is the how many? 22. We close it all over, then the 1 again minus the 2, close it. All right. Again, if you have to pause this, please do so. Look at it, think about it, listen to what I said again. Type that into the calculator. Okay, it's going to be a pretty big number. 20,971,515. Okay, problem 15. We're going to do the same thing, except we have to figure out what the first number of the pattern is, and only the first number in the pattern. So we're going to need to plug the 1 in and find that. So 10 times 1.4 to the first power. Okay, so the first number in the pattern is 14. Everything else is given to us. We just got to plug the numbers in. So we're going to start off with 14 times 1 minus. Okay, the rate or the ratio, that's in the parentheses. So 1.4. The exponent, that's the how many? 1 to 20, so 20 numbers. Close it. Divided by 1 minus 1.4. Type that into the calculator. Okay, again, I know I'm going fast here, but you can pause this at any time. So that is 29,248.89. Number 16. Each day, the now extinct Caterpillosaurus would eat 25% more leaves than it did the day before. On the first day, it ate 47 leaves. Hint: set up a table to solve the problem if needed. Use the bottom of the page for scratch work. All right, so the Caterpillosaurus will eat 25% more leaves than it did the day before. All right, well, first of all, the 25% is 0.25. Now, if it's eating more leaves, that means it's got to eat more than 100% of what it ate. So if you think about this, okay, it's eating 25% more leaves than the day before. So it eats 100% of what it already ate, plus it's eating another 25%, which is 125%. So the decimal that we're going to need for that is going to be 1.25. That's going to be the R, the ratio. Again, it's eating what it ate the day before, plus it's eating more leaves. So how many leaves did it eat on the 8th day? Well, first of all, we need to know our formula. So we're going to use the u sub n equals the u sub 0. Well, would it be the sub 0? Yes, we're going to use the u sub 0. So we're going to have to use the table here. Times r to the n power. All right, so if we did this, we're going to multiply by 1.25. So if we went forward and we took 47 times the 1.25, we get it ate 58.75 leaves on day 2. Okay, but that doesn't help us with the formula right now. What we need to do is we need to go backwards because we need the 0. So we're going to divide the 47. So 47 divided by 1.25. So on day 0, granted, that's not possible, but if there was a day 0, it ate 37.6 leaves. Okay, so now for my formula up here, the u sub 0 is 37.6 times the 1.25, day 8 to the 8th power. Now we can easily type that in to the calculator, and we find out that on day 8, this caterpillar ate 224.11 leaves. That's a lot. How many total leaves did it eat in 14 days? Well, I'm going to go back down to the table and I'm going to figure out what day 14 is. Okay, well, no, I don't have to figure out what day 14 is because this is geometric. So I only need to know how many leaves it ate on the first day. So using the formula on the top of the page, okay, the u sub 1 is 47 times 1 minus the rate, which is 1.25, and it wants 14 days, so the power of 14 divided by the 1 minus 1.25. Again, this is the same formula that we used up above. So the total number of leaves that the caterpillar ate after 14 days is 4,086.63 leaves. That's a lot of leaves. And then the notation, n equals 1 on the bottom, 14 on the top, because that's how many days we added together. And then we already figured out the rule. Okay, the rule would be 37.6, because that's the u sub 0. Look at part A. Then the rate is 1.25. And then the exponent n, that's representing each day. So we put an n there. All right. At the bottom, this is a bonus problem. Okay. So this is for an infinite series. Okay. So you're going to have this memorized. So for an infinite series, okay, looking at this problem, if you remember, the formula is u sub 1 divided by 1 minus r. Okay, you have to have that memorized. I'm not going to give that to you. So we need to know the first number in the pattern. So 20 times 0.70 to the first power. And we find that that is 14. So we're going to go 14. We're going to divide by 1 minus the rate, which is the 0.70. Again, the rate's found inside the parentheses. Type that in, and you're going to get 46.6 repeating. Okay, a better answer would be 46 and 2/3. Remember, 0.6 repeating is 2/3. All right, last page. Name the angle in 3 different ways. All right, so remember the angle formula looks like a crooked L. So you're going to need that. If you don't have the angle symbol, you're not going to get it right. So you can name an angle with one letter. So letter O, so angle O. You will notice that there's a number in that angle. You could say angle 1. Otherwise, you can use 3 letters. Okay, you can't use 2. You have to use either just the 1 or you have to use 3 letters. So you could say angle MOP. The O must be in the middle. Or there's another way you could do this. You could say POM. Number 18, name the line in 3 different ways. Okay, you use 2 letters at a time. Okay, not 3. If it's 3, I'm marking it wrong. So I'm not going to do all of them. There's a whole bunch of answers. You could say DE, make sure there's arrows on it. You could say EF, make sure there's arrows on it. You could say FG, again, make sure there's arrows on it. You could say DG, make sure there's arrows on it. Okay, there's more. There's a bunch of answers there. But make sure it's only 2 letters. Okay, number 19. Name plane P in another way. All right, so plane P is in that portion right there. All right, so there are 3 answers, and you need to write the word. So there's plane A, there's plane B, or you could say plane D. You do not need to write all of them. You only need to write it one way. Okay, identify a point in the diagram. Well, please put a dot. So there's point D. Again, you only need to name one, but there are many. There's point C. There's point A. There's point B. Okay, do not put P or Q. Those are not points. And last, okay, it's not cooperating. Just a second. There we go. Okay, collinear means same line. If it said non-collinear, not the same line. Okay, so name 3 collinear points above. All right, you only need 1 letter per line. For example, you could say B, C, F. Okay, you could say E, C, A. Collinear means on the same line. Okay, 1 letter per line. And then in the diagram above, name the intersection of GF and AC. All right, well, GF is right here. That's GF. AC is right here. So it looks like they intersect at G. Name the intersection. All right, good luck.